So let's solve one more question, and this question involves testing the continuity of exponential, sine, and logarithmic function. And the question is, determine f of 0 so that the function f of x defined by f of x is equal to 4 to power x minus 1 whole cube divided by sine x upon 4 into log of 1 plus x square upon 3 becomes continuous at x equal to 0. Now the function f of x will be continuous at x equal to 0 if and only the value of the function f of x at the point x equal to 0 is equal to the limit of the function at the point x equal to 0, or in other words, limit x approaches 0, f of x is equal to f of 0. Or we can also write, if f of 0 is equal to limit x approaches 0, 4 to the power x minus 1 whole cube divided by sine x upon 4 into log of 1 plus x square upon 3. And now to evaluate this limit, we shall make use of three important properties of limits, as per which if limit x approaches 0, a to the power x minus 1 upon x is equal to logarithm of a to the base e. And similarly, limit x approaches 0, sin x upon x is equal to 1. And also, limit x approaches 0, log of 1 plus x upon x is equal to 1. And now to make use of these properties, we shall make use of some simple tricks. We shall divide the numerator and the denominator by x cube. So now our equation becomes limit x approaches 0, 4 to the power x minus 1 upon x whole cube divided by sin x upon 4 upon x into log of 1 plus x square upon 3 divided by x square. And now the numerator is in the exact form of limit x approaches 0, a to the power x minus 1 upon x. Now the limit of the numerator can be calculated quite easily, but for the denominator we shall still have to use some more tricks. So for that, now in order to write the denominator as in the form of x to the power 4, we write x as 4 into x upon 4, and for the log of 1 plus x square upon 3 divided by x square, we can also write x square upon 3 into 3. So limit x approaches 0, 4 to the power x minus 1 upon x can be also written as log of 4 to the base e. And similarly, limit x approaches 0, sin x upon 4 divided by x upon 4 is equal to 1, and limit x approaches 0, log of 1 plus x square upon 3 divided by x square upon 3 is equal to 1. So finally, this equation reduces to f of 0 is equal to log of 4 to the base e to the power 3 divided by 1 upon 4 into 1 upon 3, and which is equal to 12 into log of 4 to the power 3. So that means the value of f of 0, for which the function f of x defined by f of x is equal to 4 to the power x minus 1 whole cube divided by sin x upon 4 into log of 1 plus x square upon 3 is continuous at the point x equal to 0 is 12 into log of 4 to the base e to the power 3. So let's solve one more question. If f of x is equal to log of 1 plus x upon a minus log of 1 minus x upon b divided by x, where x is not equal to 0. Now find the value of f at x equal to 0 so that the function f is continuous at x equal to 0. Now any function is continuous at a point if and only the limit of the function at that point is equal to the value of the function at that point. So this function will be continuous at x equal to 0 if and only limit x approaches 0, f of x is equal to f of 0. Now as per the definition of this function, f of x is equal to log of 1 plus x upon a minus log of 1 minus x upon b upon x. So we can also write this equation as limit x approaches 0 log of 1 plus x upon a minus log of 1 minus x upon b divided by x is equal to f of 0. And in the previous classes, in the lesson limits, you have already learned that the limit of difference of two functions is equal to the difference of their individual limits. So now we can also write this limit as f of 0 is equal to limit x approaches 0 log of 1 plus x upon a upon x minus limit x approaches 0 log of 1 minus x upon b upon x. And from the definition of limits, you know it very well that limit x approaches 0 log of 1 plus x upon x is equal to 1. So now we shall try to write down this expression in such a form so that this property can be applied. And in the first part, if we divide the denominator and the numerator by a, and in the second part, if we divide the numerator and denominator by minus p, then that form can be obtained. So now this limit can be also written as 1 upon a into limit x approaches 0 log of 1 plus x upon a divided by x upon a minus 1 upon minus b into limit x approaches 0 log of 1 minus x upon b divided by minus x upon b. And the limit x approaches 0 log of 1 plus x upon a is equal to 1. Similarly, the limit x approaches 0 log of 1 minus x upon b divided by minus x upon b is equal to 1. So now this equation can be also written as f of 0 is equal to 1 upon a into 1 minus 1 upon minus b into 1, or f of 0 is equal to 1 upon a plus 1 upon b, and which is equal to a plus b upon ab. So that means the value of f of 0 for which the given function f of x defined by f of x equal to log of 1 plus x upon a minus log of 1 minus x upon b upon x is continuous at the point x equal to a is a plus b upon ab.